Number 7. So consider the function f of x is equal to secant x minus pi over 4 for 0 is greater than or equal to for x is greater than or equal to 0 but less than or equal to pi. So determine the range of f is the first question that we are given. So to find the range of f, we have to first find out the 0 of the function and pi over 2. So what we have to do to find the range of the function is plug in our domain. So the domain here is limited by 0 and pi over 2. So if we plug in 0, which is the least value, and pi over 2, which is our maximum value, we should get the same for the max and min for the range. So min and max. So if we plug this into our original equation, we should get our max and min values. So if we plug in secant of 0 minus pi over 4, secant of 0 minus pi over 4, f of 0, once you plug in f of 0, you should get secant. So secant, cosecant, secant is 1 over cos. So our original value, if it was cos, would be 1 over root 2, but since it's secant and it's negative pi over 4, it should be root 2. Now if we plug in pi over 2, you should get secant of pi over 2 minus pi over 4, which in this case, this becomes pi over 2 minus pi over 4. If you do it correctly, you should get pi over 4. Pi over 2 minus pi over 4 is pi over 4. So initially what you're doing is secant of pi over 4, not negative pi over 4, pi over 4 only in this case. So once you do that, you should get the value of, you should get a value of 1. Yes, pi over 4, yeah, 1. So those are our two values, and now we plug them in. So f of x, which we're detailing our range right now. So we plugged in 0 and we got root 2. So we know now that f of x will always be less than root 2, less than or equal to root 2. And since root 2 is greater than 1, we know that it has to be greater than or equal to 1 and less than or equal to root 2, because it has to be between these two. If we put root 2 over here, it would be f of x has to be less than or equal to root 2 and greater than or equal to 1. And that would not work because root 2 is greater than 1. So I hope that makes sense then. Now let's move on to question B. Question B. So the region bounded by the graph of y is equal to f of x, the x-axis and the lines x is equal to 0 and x is equal to pi over 2 is rotated 2 pi radians about the x-axis. Find the volume of revolution generated. See, this is a really annoying question to do. You just have to remember the formula. So the formula for this is, it's a volume of rotation over here. They're asking for the volume of revolution, the volume of rotation. So they've given you what it is limited by, 0 and pi over 2. Yes? They're limited by this, and you just need to remember the formula now. So the formula is whatever your values are. It's integral pi times integral whatever your upper bound is and your lower bound, and then whatever your function is squared. So secant squared x minus pi over 4 dx. So once you integrate this function, you know that secant squared, once integrated, it becomes tan. This is something that you need to remember. So secant squared integrated, secant x integrated, is tan. So pi times secant square, tan x minus pi over 4, and from pi over 2 to 0. So I've integrated this function over here. I've integrated it, and I'm now putting it. I still haven't plugged in the upper and lower bound yet, which I have to do now. Yes. So once I plug that in, I get pi times tan pi over 4, yeah, minus tan of minus pi over 4. So if you remember your unit circle, hopefully you do. If not, I want you to go and review your unit circle because it is key for this part over here. So we know that tan pi over 4 is root 2 over 2 divided by root 2 over 2 on the unit circle, because tan is sine over cos. Is equal to tan. So tan, sine of pi over 4 is root 2 over 2. Cos of pi over 4 is root 2 over 2 also. So this is equal to 1. So it is pi times 1 minus pi over 4 will be the same. It will just be negative. So negative 1. So essentially what you get here is negative and negative make positive. So you get 2 pi as your answer. What an amazing value to get after all that working out. Eh? Hopefully you've gotten that. Yes? So now let's move on to question